Hi, welcome everyone to episode 1 of AppSec Secrets, Cycode's brand new webinar series. I'm Julie Peterson, and I will be your host today for Hidden Dangers, Hard-Coded Secrets in AI-Generated Code. Before we get started, I just want to share a little bit about Cycode. Cycode delivers a security-first, developer-friendly approach to application security, and this series brings together security, IT, AppSec, DevOps, and business leaders to flip the script on AppSec. Our goal here is to share best practices, challenges, threat intel, and much, much more. As a reminder, you can ask a question at any time. Just put the question in the question box on your screen, and we will answer them at the end of the presentation. And if for some reason we don't get a chance to answer your question live, we will follow up with you after the webinar. So without much further ado, I'd like to introduce myself. I am Julie Peterson. I am a Senior Product Marketing Manager here at Cycode. I've been working in tech my entire career, and I've spent the last few years writing about security, open source, big data, and AI ML. I am here with Lotem Guy today. Lotem, would you like to introduce yourself?
Yes, of course. Thanks, Julie. I'm Lotem Guy. I'm the VP of Product for Cycode. Over 20 years of experience in the cybersecurity field, from offensive to defense, in the military service and in the business companies. I'm very happy to be here today.
Great. Thanks so much. So our agenda today is we're going to define hard-coded secrets and look at Cycode's secrets management maturity model. We're then going to jump into the meat of the matter and look at the impact of LLMs on generating code and how you can reduce the risk of secrets in AI-generated code. So by virtue of you just being here, you understand that secrets are a problem, right? You don't have to go too far to see headlines where secrets have been involved in an attack. I'm going to focus on just one here, and that's the CodeCov attack, and that's what I like to call secrets all around. With CodeCov, the attackers found a secret. I think it was from I think maybe a Bitbucket server, or anyway, they found a secret leaked online, and what they did was they then infiltrated CodeCov and they altered a bash uploader script so that they could then target downstream customers. And what they were targeting with the downstream customers were login credentials. So again, they used secrets to start the attack, and secrets were the ultimate goal. So again, secrets are, really a significant problem, and we all are kind of getting more awareness and concern about them. Before I go too much further, I just want to make sure that we're all level set on what secrets in code are. When we think of secrets in code, most of us go to authentication related secrets like usernames and passwords, or authentication tokens and API keys. You might even think about encryption certificates and encryption keys. But I think we should even expand this definition to include custom secrets that are specific to your organization. Things that you don't want exposed publicly because it presents either some kind of risk, or if it's exposed, you might have to suffer some sort of fine. And so you should start thinking about secrets as things like personally identifiable information, PHI, ID numbers, activation codes, discount codes, basically anything that's specific to your organization that represents a risk should it be exposed publicly. Now that we've level set on what secrets are, I want to jump into Cycode's secrets management maturity model. Our maturity model has 5 layers, and each layer builds upon the previous one. So it starts with general awareness and it goes up to risk management. So again, it's a cumulative effect, and I'm going to jump in and talk a little bit about each level individually, starting with level 1 awareness. By virtue of you being here, you're already at least at level 1, so congratulations on that. Level 1 is understanding that the way modern applications work has changed significantly over the last couple of years, and that as a result, authentication needs have increased. So think of things like microservices, IAC, cloud, and more. And at the same time, you also know that your developers are probably hard coding secrets. You know it's an issue, but you don't necessarily know the severity of it. And perhaps you've even put policies in place and done some developer training to try to get ahead of it. But because you have no detection or enforcement mechanisms, you have no way of knowing how significant the problem is. So the next level is level 2, basic detection, and that's where you adopt a secret scanning tool, and you're looking at the most obvious place where secrets are in your code. So you're scanning your repos. Perhaps you're including version histories, but not necessarily always. In terms of what you're looking for, you're scanning for common secret formats, things that have a known pattern that you can more easily find, like API keys, passwords, authentication tokens. And your scanning tends to be either ad hoc or time-based, so maybe you're scanning before every build, or you're scanning weekly at a certain time. Level 3 is taking this foundation and advancing it. So level 3 is advanced detection. Here you are expanding the depth and breadth of the secrets that you're looking for. So you're looking at more locations across the SDLC. You're looking at both private repos and public repos. You're definitely looking at version histories. Things like infrastructure as code, Docker images, and storage buckets are also things that you're scanning, because guess what? Secrets can live there. You also should be looking at this level at productivity tools like Slack and Confluence. So it's not uncommon for a developer to reach out to a colleague over Slack and say, hey, I need the credentials for XYZ tool, and that colleague Slacks it back. Now, while that's an efficient way and a quick way to get that information, the problem is that Slack isn't secure. So it does represent a risk to your organization. At this point, you also need the ability to scan for custom secrets. So remember, I said a secret really is anything that's specific to your organization that you don't want getting out. Well, you need the ability to define what that secret is so that we can find a secret that is specific only to your organization that maybe other organizations don't need to worry about. At the same time, prioritization and remediation comes into play. What we find is when most people do an initial scan, they're pretty overwhelmed with the number of alerts that they've received. And so waiting through all the results and making sure that you're focusing on the thing that matters most first is quite a task. And so you need the ability to prioritize these secrets so that you are remediating something that, say, is internet facing on a production server first before you're looking at something that maybe is in a test environment. Level 4 enforcement assumes that you've got a pretty robust scanning system in play, and it now moves on to policies as a way to prevent hard-coded secrets. So this generally requires you to have some kind of developer workflow integration. So maybe you're scanning at every commit or every pull request, and perhaps you're even running policies where you're blocking on failed tests. So the developer has to fix the secret before the code is merged back into the main branch. Now, as part of this, you need a secrets manager. You have to give developers a way to properly and securely manage their secrets. Now, secrets manager is not technology that Cycode does, but it is complementary to our scanning. And again, you need to have a way to properly manage secrets if you're not letting developers hard code them anymore. Level 5 is risk management. And at this level, you have stopped thinking about secret scanning or secrets as a discrete problem, and you start thinking about how it's fitting into your AppSec program and your vulnerability management program as a whole, right? So here, threat and risk are aligned with your business goals. Scanning is continuous, preventative, and integrated into your best practices. So that is a really quick overview of our secrets management maturity model. And I'd love to jump into secrets and AI. It's really hard to turn around these days without hitting a headline. And this is just from a couple of days in the New York Times a few weeks ago. Clearly, AI is on top of mind for everybody, right? AI is either going to save us or it's going to ruin us. We're just kind of waiting to see. So, it got me thinking, what does this mean for developers? And the truth of the matter is, it's no longer a question of when are developers going to start using tools like ChatGPT or Copilot to code, but how can you manage it? They're already doing it. So if you go to YouTube, there are thousands of tutorials on how you can use these tools to optimize code, document, comment, write README files, even generate tests, fix bugs, or explain existing code. So it's out there. Developers are using it. And that kind of got me to thinking, can we really trust these tools to securely develop code? And I'm going to go on a little bit of a side journey, and bear with me on this, but I hope it shows a point that I'm trying to make. And a couple of weeks ago, I was doom scrolling, as you do, and I was served a video clip of what looked like a television show I had never heard of before. And in this clip, a man walks into a restaurant, it's a diner, and he's holding a bottle of Maker's Mark bourbon. And it's got a big red bow on it, and he goes up to one of the waitresses and says, "Oh, I'm really sorry. You're right about the house. I have to apologize." And it's this really heartfelt apology. And she, kind of graciously accepts it. And then he continues on and says, "Oh, and I think, by the way, this is a great time for us to get divorced." And she has no reaction. She just sort of agrees. And it was such a darkly humorous moment that it sucked me in, and I wanted to know what it was. But if you've ever been served these clips, they're trying to get you to click on a suspect link, and they don't tell you what the title of it is. So I then tried to use a Google image search. It didn't work. So I thought, okay, maybe this is a job for ChatGPT. So I went to ChatGPT and said, what is a TV series where a woman who works in a restaurant, her husband comes in and asks her for a divorce? Now, ChatGPT came back and said, it's The Marvelous Mrs. Maisel. She doesn't work in a restaurant, and it takes place in the 50s and 60s, but her husband does ask her for a divorce. I've seen The Marvelous Mrs. Maisel. I know this isn't right. So I go back to ChatGPT and say, no, the show is set in the present day. ChatGPT comes back to me and says, oh, what you're referring to is a show called Younger, but the person doesn't work in a restaurant. She works in publishing. I know this is wrong. So I go back for round 3 and add in a little bit more detail. And I remember that the husband asks for his grandmother's ring back. So ChatGPT comes back again and says, oh, the show that you're looking for is called Sweet Bitter. And in it, the main character's boyfriend asks for his grandmother's ring back. Well, I know it's clearly a husband, so this one isn't right. I Google an image, surely it's not the right actor. So I go back again, and I think that Maker's Mark bottle is going to be the thing that gets it through, right? I mean, how many shows have a husband giving a gift of Maker's Mark as a gift when they're asking for a divorce? Apparently, that number is greater than 1 because ChatGPT came back and said, you're referring to The Heart of Dixie, where the husband did exactly that with the Maker's Mark bottle. Oh, and the main character is a doctor. Again, I know this isn't the right show, so I go back for round 5, and this time I decide I'm going to add in that the restaurant's a diner, get a little bit more specific there. I'm going to reiterate that the wife works at that restaurant, and I throw in that the husband wants to marry his girlfriend. And ChatGPT comes back to me and says, you're talking about Divorce with Sarah Jessica Parker. And I know this isn't the right one. And in a last-ditch attempt to figure out what this show is, I somehow pull from the back recesses of my brain that I think the wife's name is Fiona. So I put that in, and sure enough, ChatGPT comes up with the right show. It's Shameless. I Google it. Finally, I found my answer. So why did I tell you all of this? I told you all of this because I wanted to show you that AI can and will be wrong, and when it is wrong, it does so with complete and total confidence. And the problem here is that humans trust generative AI more, when the reality is they should trust it less. You can just talk to Stephen Schwartz, the ChatGPT lawyer who made headlines because he used ChatGPT to write a brief that he filed in federal court. His college-age kids were like, hey, Dad, this is a great productivity tool. He tried it. It came up with some great case law for him, and he, even kind of checked into it because one of the cases he hadn't heard about before, it was something like Williams v. Gonzalez, and he even went back and asked ChatGPT, is Williams v. Gonzalez a real case? And ChatGPT said yes. Well, he filed the brief. He got called in front of a federal judge. He was embarrassed. There was talk about him losing his license. I think it all ended well, but certainly it's a caution for all of us. So we all know the adage of trust but verify. I think here, when we're talking about AI, at this point in history, you have to change that adage to do not trust, verify. And I think that's a really great segue to talk with my colleague, Lotem Guy, and get a little bit more into the meat of the matter. So thank you so much again, Lotem, for joining me. The first question I want to ask you is AI the future of coding?
I believe so. I think that you're right. We cannot just hit and forget, and there's definitely verification needs to be done. But I do think that AI is the future of coding, and developers will write more and more AI-based code or deliver more AI-based code to their production environments.
Yeah, okay. So it's the future of coding. We're seeing that already. That's not a big surprise, right? So how can we use it in vulnerability management, specifically, thinking about that hard-coded secrets problem?
Yeah, so I think it's two different things. One thing is for coding. I think coding with AI can really increase the productivity of a developer. It just really helps. It's not going to replace developers so soon, but it will increase their productivity. The developers will be able to write more code with a good use of generative AI tooling. On the risk management is, I think, a different story. There are a lot of things that we can do for avoiding risk and reducing risk based on AI. Okay, so we can use AI for the triage process. We have an issue, we have a security issue, maybe we have some alerts from a security system, and now we need to understand that. That's the basic, that's the first step that every security analyst is doing every morning when she gets to the office. And that's not a trivial task. It might be easy in some cases, but the more complicated cases, which are the interesting one, are really not trivial and hard to understand. And I think that AI can help with that. If we can train the right model and ask the right question, we might be able to get good answers. And again, needs to be verified, but can really improve our efficiency and help us get to the right answer much faster. That's for the triage. Now, after we triage, we understand the alerts, we want to fix it, right? We want to fix the problem. Again, AI can really help with suggested remediation. If we explain the problem, we might get a very good answer and better understanding of what we need to do next. Next level. Yeah, sorry, go ahead.
No, I was going to say, so how do you using AI to get this answer, how do you know whether to trust it? Like, what does that process look like?
I think you need to understand the answer. It's not that I'm asking a question, I'm getting an answer, I'm filing that to court. We saw that from your example that has a risk in it. We get the remediation suggestion from ChatGPT, for example. We need to read it, we need to understand it, really address our problem, okay? But it can really speed up the process because in many cases it will have very good ideas, okay? And I know it took you 6 rounds to find your the series that you liked, but I hope the 6 rounds were fast. You got good ideas and it really helps you think fast of a solution, and then you can implement what you really understand as the right one. So you still need to be a professional. It's not gonna be, people that don't understand security that can somehow do security, but it's really can help those security professionals and improve their capabilities.
Okay. So we won't be hiring people fresh out of university to run our whole AppSec program. We all still have jobs for the time being.
We still have jobs, but we'll have more code to secure. So we need those students to wrap up fast.
Fair enough. I totally agree with that. So, sort of digging deeper into that problem with AI being insecure, right? And security, something that we all worry about day in and day out. Is AI the right market fit for security?
I think AI can really help in many different things. And specifically, we're talking about LLMs, generative AI, and like the AI that really understand the language, can be the English language or code languages. And I do think that like technology can really help in security. Right? From our perspective, we want to write secure code. We do not want to have secrets exposing our code or in our pipeline or in our production environment. And if we train those models right and we guide them to avoid those risks, I think we can get to better and more secure coding.
Yeah, that sounds great. So I'm going to kind of dig a little bit deeper into the problem, right? So there are people out there that say humans are the real problem when it comes to LLMs and generative AI, right? We're either programming in our implicit biases or our bad practices, right? Thinking about our bad practice of hard coding secrets in the first place. Or even worse, that you have malicious actors who are intentionally trying to skew the models. Right? So this is kind of a multi-part question. How can we make sure that we're using AI for good, especially when it comes to secure coding? And then, how can we make sure that we're training it the right way so that we're not putting, secrets in code or basically adopting insecure coding practices?
Mm-hmm. That's a very good question, because we know that machine learning models and LLMs, they are biased based on their training set. So ChatGPT and the like, they're trained with a huge amount of features on a huge amount of data, which means that they are less tend to be biased, except for the fact that the data is biased, right? The data in the internet is biased. We know that there's bias towards the people in the world that are using the internet and putting content in the internet more than others, and we can split that to geographies and genders and stuff, so that even though it's a huge data set, there's still bias in that. So that's in general. In coding as well, right? If we assume that there are a lot of security vulnerabilities in code today, it also means that those models will learn from bad examples and might create those vulnerabilities as well. Specifically for secrets, and I did this test. If you ask for ChatGPT or Copilot or Bard for a code snippet to authenticate to a service, they will use secrets in your code, because that's the most basic way to authenticate to a service. Just put the password in your code. That's not wrong. It will work. It's just not secure, right? So we have to be aware of that. Now, those, like, the reason that they do it, it's the right thing to do, but they learn from those type of code snippets from specific documentation. Usually when I write documentation to how to use my service, I will put in the code snippet the place to put the password. And maybe I'll have a comment of don't put the password there, store it somewhere else, but still the code looks like that, and that's how those systems learn. And then that's the code that they're generating. But I think there's still, if we are aware of this, we can solve this problem. If we guide the tool not to include secrets, for example, or specifically use the secret management tool that we are using, we can hope to get the right code that uses that management system and does not place the secrets in your code.
Yeah, it's really, really interesting. So in your experience, or your opinion, how do you think that there are malicious actors out there trying to skew results? It kind of goes back to one of your earlier points, or is that just something that we're worried about for no reason?
Malicious actors that are trying to manipulate results as like manipulating the training set, that will be a challenge. we talked about the biases, but just to plant something malicious there, and hope that it will create other code to use that specific code snippet is, I think it's realistic. We can think of other type of bad actors that's, for example, penetrating to one of those services, let's say for ChatGPT, and then manipulating with the results of ChatGPT, not necessarily in the learning models, but in the output of the application itself. And ChatGPT is huge and well-known and everyone using, but there are plenty, dozens and hundreds of other platforms that are either using ChatGPTs or using their own models, and I'm sure not all of them are very secure.
Yeah. Okay, so this brings me to my final question, and actually you shared a slide with me that I'm going to share with the audience, but speaking specifically about hard-coded secrets, what are some of the actionable things we can do to minimize the risks of hard-coded secrets in AI-generated code? And I'm going to share my slide with you. Okay, here we go. So this is your top 5 list.
Yeah. Yeah, I think if you do those 5 things, you'll be okay. All right. So first, we talked about it in general, but specifically in the context of hard-coded secret, every code that is generated needs to be reviewed or tested. And it's very easy to spot hard-coded secret, and I'm sure that good developers that are using ChatGPT and others to generate their code, reviewing the code will reduce a lot of the risks, specifically with hard-coded secret. Now, we can also, when building more dedicated models, try to train the data based on more of the clean and secure code snippet that does not include hard-coded secret, or in the prompt to optimize that to explicitly tell the model to generate code that does not include secrets or that is using secret management tool. So I think that will definitely take you to the right place. Tuning models when possible is important, usually much harder to do, and most people would just use the existing tools, existing models. But at the end of the day, you have to scan for secrets. Like we can do all those right things, and we still might have vulnerabilities, specifically secrets in our code or printed to our build logs or integrated to our container images or anywhere in the pipeline, and we have to scan them. We have to search for them, as you shared in your slides before. Like that's the best practice. That's how we can create a more secure applications.
Great. So it sort of seems like we have to treat it much like AI, much like a developer, right? You have to follow up and not quite trust, but make sure that you're verifying that this isn't happening. Yeah,
it's a great companion to work with and to write code with, and can really drive us faster. But as always with the pair programming, we have to review each other's code and verify it's secure.
Great. Well, thank you so much for all your insights on how to minimize the risk of hard-coded secrets in AI-generated code. Before we go on to the Q&A, I just want to show you that, share with you a little bit about Secode. We offer everything you need to secure from code to cloud. This includes supply chain security, application security, cloud security, and security intelligence. If you would like to learn more, either about hard-coded secrets or about Secode in general, please feel free to visit us at secode.com/resources. And I think we have a couple of minutes to answer some audience questions. And so let me just take a look and see if you have any questions. This is a great time to add them into your chat box, and we'll answer as many as we can. Okay, so looking here, The first question I have is where, sorry, I'm just going to lead in and read this a little bit, but where do you think most companies are on your secrets management maturity model, and how can they improve their posture with this? Lotem, do you want to take this one, or I can take a stab at it?
But I can do that. You'll take the next one, Julie. So I think that the awareness for hard-coded secrets as a problem is high today. When I talk to customers, when I talk to CISOs, they're aware of the problem. Not all of them are doing much about it, but it's high in their awareness, and for many of them, that's a project for this year or next. So I'm encouraged that we're in a better place than we used to be a couple of years ago, but there's still a way to go.
Yeah, I want to reiterate that. In my experience, I've been talking about secrets for, almost 2 years now. And I think in the beginning, there was a lot of education being done about why they're a problem. And I think we've definitely come full circle and we realize that they are a problem, and we're seeing more and more that people are tackling them as a project in AppSec. So yeah, I mean, so I think the greater awareness is really good. I think if you have scanning, most of us are probably somewhere around that level 3 at best, and very few of us have moved on to where we're, really churning out and looking at secrets and reached that alignment with business goals and risk. So yeah, great question. Okay, I have another one. We use a vault solution for our secrets. Do we still need to scan for secrets? I can take that one if you want. I think the short answer is yes. Even if you have a solution where you're managing your secrets and you're able to, rotate them out quickly if they've been burned, the fact of the matter is that you need visibility into your entire SDLC and beyond to see where those secrets are. They persist, they're out there, you need to scan for them and remediate them. Great that you've taken a first step of having a secrets manager, but you need that complementary technology of being able to scan for them. Okay, here's one. What is the best way to make sure your developers are not hard coding secrets? Is this a people issue or a process issue? Lotem, do you want to take that one?
Yep. So that's a very good question. I think it's both a kind of educational and processes. Educational because people need to be aware, the developer needs to be aware. They need to be aware that this is a risk, a significant risk. It's a risk that is easy to understand, right? If I give my credentials to an attacker, I give them the keys to my castle, they go in from the front door. Obviously, that's not what I want to do. So it's very easy to understand the risk. And then the processes get along because it's not trivial to fix it. If I'm a developer that I need to use a service and I have the credentials, or I put it in the code, now if I need to take them out of the code, I need to put them somewhere so my application will work when it's running in production, right? So where do I put them? So we talked about secret management tools and the example of a vault. That's great, I need to place them there. But do I, as the junior developer in my organization, have access to the vault? Am I authorized to add any service key there? Not necessarily. So that's where the process comes along. And every developer needs to be aware of the problem, but also understand how to solve the problem, what they need to do if they actually need to access this service.
Yeah, I completely agree with you. So I think we have time for one more question. And this one, Lotem, I think is right up your alley as the head of product here at Secode. And the question is, can you provide more details on how Secode scans for secrets? Like where and what?
Yes, of course. So when we're scanning for secrets, first we're looking for any type of secret, okay? Usually tokens, credentials to services. We want to be very accurate, so we're trying to not just detect the secret, but also identify what service is it used for. When we do that, we can also verify if the secret is valid or not. If it's not active anymore, the risk reduced, right? If it is active, then there's a higher risk in that. We have a lot of machine learning based algorithms to identify the secrets, to map them to the right service, and to do the validation. And one thing that is very unique in Security is our ability to do that across the pipeline. So not only in code, but also in the build process, analyzing build logs, in the registries, when we analyze container images before they're deployed to production, so we can identify that there. And even in productivity tools like Slack that you mentioned, we can identify secrets that are placed there. So the breadth of detection, the fact that we detect across the pipeline and all the development lifecycle, I think that's very, very important for our customers.
Great answer. Thank you so much. And with that, we are concluding our webinar today. I want to thank you all, first of all, for joining us. And I especially want to thank Lotem here for sharing his expertise and insights into this really, really important product. Again, if you would like more information about Secode or any of the things we talked about today, please go to secode.com/resources, and there's a whole heap of information there to keep you busy for some time. And as always, please keep an eye out for our next installation of AppSec Secrets coming next month. Thank you all so very much and enjoy the rest of your day. Bye.